In this video, we're going to find the derivative of all of these functions. Each of these functions contain a logarithm, so we're going to be practicing derivatives of logarithmic functions in this video. Okay, so let's find f prime of x. These are the properties related to logarithmic functions that we're going to use. So this is the derivative of a general logarithm, log base b of x. Here's the derivative of the natural log of x, and here's the derivative of the natural log of the absolute value of x. So we're going to need to use the chain rule to do this. We've got the sine of something. It's cosine of that something times the derivative of that something. So the derivative with respect to x of natural log of x is 1 over x. And there's no more chain rule here. So this is the derivative. Let's just write it in a clean form. So that's the derivative. Okay, let's find f prime of x. We need to use the chain rule. We've got the natural log of something. The derivative of the natural log of something is 1 over that something. So 1 over that something. All of that times the derivative of that something. What is the derivative of, with respect to x, of 1 over x? Well, I know this off of memory. That's minus 1 over x squared, but you could look at it this way. What is the derivative of x to the minus 1? That's minus 1 times x to the minus 1 is minus 2. So that's minus 1 over x squared. So this is just x times, so we've got, so f prime of x is minus 1 over x. Okay, let's find f prime of x. We've got log base 10. So we're going to need to use this derivative. And this is for any general logarithm of base anything, log base anything. A natural log is just log base e, right? Log base e of x is 1 over x times natural log of e, that's 1. So you just get this. Here we've got log base 10, so we need to use the chain rule. We've got log base 10 of something. What is the derivative with respect to x of the log base 10 of something? It's 1 over that something times the natural log of the base times all of that times the derivative of that something. What is the derivative of 1 plus cosine of x? That's 0 plus minus sine of x, right? So we've got 1 plus cosine of x, natural log of 10, and then that's the derivative. Okay, let's find g prime of x. We've got the natural log of something. We're going to use the chain rule. Natural log of something. What is the derivative with respect to x of the natural log of something? It's 1 over that something. All of that times the derivative of that something. What is the derivative of x times e to the minus 2x? Well, we need to use the product rule. The derivative of, here's the first function of x, here's the second function of x. The derivative of the first is 1 times the second plus the derivative of the second. What is the derivative of e to the minus 2x? Well, we have to use the chain rule. What is the derivative of e to the something? It's just e to the something. So e to the minus 2x right? So e to the minus 2x times the derivative of that something. What is the derivative of minus 2x? That's minus 2, okay? Times the first, right? The derivative of the first times the second plus the derivative of the second times the first. So we've got minus 2x e to the minus 2x. Okay, so now let's factor out an e to the minus 2x. One minus 2x. So these cancel, so we've got 1 minus 2x over x. And that's the derivative. Okay, f prime of t. So we need to use the product rule here. Here's one function of t, and here is another function of t. Okay, well, what we could do is let's what is g prime of t? Let's do it like this. Sometimes this makes it easier. So what is the derivative with respect to t of the natural log of t squared? We need to use the chain rule. So we've got the derivative of something squared. What is the derivative of something squared? It's 2 times that something times the derivative of that something. And the derivative of natural log of t is 1 over t. Okay? Now, what is the derivative? What is f prime of t? The derivative of sine of t is cosine of t. So f prime of t is the derivative of the first times the second plus the derivative of the second times the first. So f prime of t, all right, 2 natural log of t over t, that's g prime of t, times f of t, plus f prime of t, which is cosine of t, times g of t, natural log of t squared. So let's see, how can we clean this up? We could factor out maybe a natural log of t cosine of t. So that's 2 over t plus natural log of t. Wait, okay, hold on. No. This should be sine of t. I don't know what I was thinking. So the derivative of the first times the second plus the derivative of the second times the first. So now we can factor out a natural log of t, and you've got 2 over t sine of t plus natural log of t cosine of t. And that's the derivative. Okay. The natural log of the absolute value of this 1 plus t minus t cubed. So the derivative with respect to x of the natural log of x is just 1 over x. So we don't have to worry about the absolute value when it comes to derivatives of logarithms. It just goes away. The absolute value just goes away. So, okay, y prime, we need to use the chain rule. So the derivative of the natural log of the absolute value of something is just 1 over that something, and just remove the absolute value. but then times the derivative of that something. So the derivative of 1 plus t minus t cubed is 0 plus 1 minus 3t squared. So y prime is okay, what is g prime y? So this is just, this is just a more difficult problem. There's more steps, but there's nothing more complicated than anything we've learned so far. We start with the chain rule. We have the natural log of something. What is the derivative of the natural log of something? It's 1 over that something. So we're just going to get the reciprocal of this. That's what we're going to start with. So 2y plus 1 to the 5th right? That's 1 over this. You just take the reciprocal times the derivative of that something. So this is confusing, right? All of this inside here is like, well, let's call it u, right? So when we're taking the derivative, we're saying 1 over u prime. So we're going to take this, the derivative of this as a whole. So like it's pretty much starting a brand new problem because this step is kind of its own problem. So, right. So we did 1 over this times the derivative of this. So now let's just clear our brains, right? Put a big bracket here because we're going to be multiplying all of this times this. And what's the derivative of this? Well, we need to use the quotient rule. So, okay, the derivative of the top is what? Okay, chain rule. What is the derivative of something to the 5th power? It's 5 times that something to the 4th power times the derivative of that something. What is the derivative of 2y plus 1? 2. Okay. That's the derivative of the top times the bottom. Okay? Minus the derivative of the bottom. What is the derivative of the square root of something? It's, so, okay, we're going to minus, let's put a curly bracket here, and we'll put, because this minus is going to apply to everything we're doing here. So derivative of the top times the bottom minus the derivative of the bottom. So the derivative of the square root of something is, it's minus 1 over 2 square root of that something. So x to the 1/2 x to the minus 1/2. Yeah, or no, it's not minus 1 over 2 square root of x. It's just, okay, so it's just 1 over 2 square root of that something. Okay, so we'll have a 1 up here, but times the derivative of that something. What is the derivative of y squared plus 1? It's 2y. Okay, so where are we here? The derivative of the top times the bottom minus the derivative of the bottom times the top. All over the bottom squared. Okay, so now that's the derivative. Let's just do some algebra to simplify this as much as we can. So we distribute this y squared plus 1, the square root of y squared plus 1, and what do we get? We get, so this here is 10 2y plus 1 to the 4th. And then so now times y squared plus 1. Okay. minus, now these, the square root of y squared plus 1's cancel here. These cancel. So this is just minus y 2y plus 1 to the 5th. Okay? And then we've got 2y plus 1 to the 5th times y squared plus 1. Okay, so now what we can do is separate this into, well, actually, we could, let's factor out a 2y plus 1 to the 4th. So we've got 10y squared plus 1 minus y 2y plus 1 all over so now this cancels and we're left with a 1 here. So we've got 10y squared plus 1 minus y Okay, now we could separate this into two separate fractions that are subtracting. So if we, okay, so we'll do okay, and then okay, so here these cancel, and then here these cancel. So we've got yeah, there we go. That's the derivative. Okay. F prime of S. So just like a double chain rule, or yeah, I think it's double, or maybe just, we'll see. Okay, so what is the derivative of the natural log of something? It's 1 over that something times the derivative of that something. What is the derivative with respect to x of natural log of s? It's 1 over s. So this is an easy one. S natural log of s, that's the derivative. Okay, so we've got one function of z times another function of z. Okay, so let's just do this. Let's say, what is f prime of z? Well, 2 to the z power, what is the formula for the derivative of an exponential, like a general exponential? It's rewrite the exponential times the natural log of the base, right? So f prime of z is 2 to the z natural log of 2, right? If this was e to the z, natural log of e is 1. G prime of z is, so it's 1 over z, so z and then natural log of 2. 1 over z natural log of 2. Okay, so the derivative of the first, 2 to the z natural log of 2, times the second, plus the derivative of the second, times the first. Okay, so we can factor out a 2 to the z, and we're left with natural log of 2 log base 2 of z plus 1 over z natural log of 2. Okay, now what can we do with this here? Well, we can use the change of base formula on this log base 2 of z. So log base 2 of z, and if we wanted to change this into a natural logarithm, we would say this is equal to natural log of z over natural log of 2, right? That's the change of base formula. So if we put that in here, so times natural log of z over natural log of 2, then these cancel, and now we're left with there you go. That's the derivative. Okay. What is the derivative of the natural log of something? It's 1 over that something. Times all of that times the derivative of that something. What is the derivative of e to the minus x plus x e to the minus x? Okay, the derivative of e to the minus x is just minus e to the minus x, right? E to the minus x times the derivative of minus x is minus 1. Plus, product rule. The derivative of the first, 1, times the second, plus the derivative of the second times the first. Okay? So we've got okay, so these go away, and we're left with okay, but we can factor out an e to the minus x. So these cancel, and we've got, and that's the derivative. Okay. The derivative of the tangent of something is equal to what? It's secant squared of that something times the derivative of that something. What is the derivative of the natural log of something? It's 1 over that something times the derivative of that something. What is the derivative of ax plus b? A and b are constants. That's just a. Okay, so y prime is okay. That's the derivative.